All right. Okay. I have more stuff to talk about regarding OOP in Python. This is like my favorite thing. Or I guess, again, it's something that Python does really, really well. We did not, here, I want to point out one more textbook that we did not use. It's called Fluent Python. It is a beast of a book, okay? It's really, but you can get it for free, or you read it for free, I would say, while you are a student here at UCLA. Let me see. Okay, wait. But it's this Fluent Python, second edition. Hold on. I forget where's. I have a link somewhere in the syllabus that links you to the O'Reilly Learning Catalog, and you log in with your UCLA ID. Let me see, UCLA Library, and let me see. If I type in Fluent Python, can we get it? So we want this available online. So you want the, I would say you'd want the second edition, not the first edition. Second edition, April 2022. Available online. Oh yes. Then you'll click this, O'Reilly Online Learning, and it should take you to your familiar sign-in page. You'll sign in. And then, ta-da, you can start reading it, okay? So, hold on. I don't want to read it here. No, not playlist. You can have book playlists. Table of contents, that's what we want. Okay, so the Python data model. So this book assumes a base knowledge of Python. So that's why I didn't use it as a textbook. But once you complete Stats 21, I would say you have the requisite knowledge to gain and to appreciate this book. Okay, and so the Python data model really gets into kind of like the Dunder methods. So these are kind of the things that, again, Python does really well when you create classes and stuff, right? So he's I guess people like to use cards as an example. So he creates a class for a new deck, and then puts in Dunder init, Dunder length, Dunder get item, and things like that. Okay, so let me let's resume here. And anyway, that's just another book for you to read and learn from. Okay, so this is our card class so far. Cards will have a suit and a rank. We have an initialization method, a string method, and methods for comparison and equality. And then we've also defined a deck, and the deck contains cards. And as far as the methods that we have in the deck, we have the init and string to print out, and then we can kind of pop cards, add cards. We can shuffle the cards in the deck. We can sort the cards in the deck, and we can move the cards. Okay, and then a hand is basically a miniature version of the deck, but not doesn't contain any things. And so we can create a new deck, create a new hand. We can move 5 cards from the deck into the hand, and then now I can print out my hand. And because when I created a new deck, we didn't do any kind of shuffling. We're just kind of dealing the bottom 5 cards or the top 5 cards, and so we get king, queen, jack, 10, and 9 spades. Okay. Oh, this is I did a little bit of this in Wednesday's lecture, but one of the issues that with our current definition of the card is that when you ask for the card object, it gives you this stuff like double under main dot card and things like that. Okay, And then when you want to, if you want to like look at the list of cards in a hand, it is again completely kind of incomprehensible. It just gives you these address memory locations, right? It says you have a card at this memory location, a card at this memory location, things like that. And so another important method is the repr method, okay? And this is the representation object, or representation method. And this kind of, a nice way to think about this is dunder string is how your end user wants to see the object. So you want to see it like king of spades, jack of spades, nine of spades, things like that. Whereas the repr object, or repr function or method should return how a developer or programmer wants to see the object. So in our case, it is going to be basically the command that we use to create the card. All right. So it's going to return a string, but it's going to be basically card self.suit and self.rank is basically going to be our representation object. So I'm going to create a new card, and this will be card 3,11. And so when I ask for a card, it will say card 3,11. This is the command that we use to create this card, and so this allows us to see it. When I call print on it, it tells me it's the jack of spades, but that's what we have. Card 2 was created under the old definition, but we still have kind of a test for equality, and we can see that card 2, even though it is unintelligible to us, because we have the test for equality, which basically creates a tuple out of the suit and rank, it can see, oh yeah, we have a 3 and 11, 3 for the suit, 11 for the rank. Card 3 also has a 3 for the suit and 11 for the rank. Therefore, the test for equality says that they are equal, or equal to each other. One is not the same as the other. They are two different instances of the jack of spades, but as far as are they equivalent to each other? Yes, they are. Okay. So we'll redefine our deck class to use our new definition of the card. We'll redefine our hand to use kind of our new definition. And so now I can create a new deck, create a new hand, and then when I print out the hand, we get the print output: king of spades, queen of spades, jack of spades. And then, but if I also just call for the list, I get a list that is a little bit more human readable than main.card at memory address location. We at least have the repr objects, or repr not repr objects, but what repr returns, card 3,13, card 3,12, 3,11, 3,10, 3,9, to say, these are king of spades, queen of spades, so on and so forth. Okay. Right now, if I ask for what is the hand, I get this hand object, and if I ask for something like length of hand, I get an error. Okay. If I ask what are the values, vars of hand, we can see we have cards and we have labels, and I could ask what is the length of hand.cards. Hand.cards is this list, and hand.cards, it will say, that list has 5 things in it. And so we might want to say like, hey, sometimes I might just want to call length on hand to see like how many cards are in the hand, okay? And so you can do that by adding double under length, okay? Dunder length. And so this is basically, we are now treating this class hand as a container that contains other things. And if it contains other things, you might want to know how many things does it contain. And so in this case, we're going to ask it to return basically the length of this part, self.cards. Okay. And so now I can create a deck, and I can say, what is the length of deck? There's 52 cards. I can create a new hand. I can move 5 cards from the deck into our hand, and I can say, what is the length of hand? There's 5 cards in there. I can ask, what is the length of deck? and now there's 47 cards remaining, okay? So, these are all part of how Python wants you to create your objects, okay? It wants you to create your objects in a way to kind of use these already existing things in Python, okay? Like, you don't have to, okay? There's no law, and Python's not going to throw errors if you create deck.length, right? And you can say, hey, if I want to know what is the length of my deck, I could have just called it define deck.length or something like this, right? I could have created my method this way. And then you could call, ask for deck.length, and it would work. However, the fact that Python has these dunder methods, these double underscore methods, is Python's kind of guidance to encourage you to use these things, which will then integrate really well with all of these other things that exist in Python, right? So the double underscore add method, the dunder add method, will suddenly allow you to call things like sum and these other methods that work together. When you have the if you use dunder less than, it allows you to implement sort and these other kind of these functions and things that already exist in Python, rather than you kind of reconstructing everything yourself. Okay. Other things that kind of is integral to how we interact with things in Python is this concept of slicing, right? So if you have a list, you can slice it. And we might say, well, hey, I've got a deck of cards. Can I slice my deck of cards, right? And if I try to do something like, hey, give me the first 5 cards from the deck, okay, I get an error. It says right now deck is not subscriptable, right? And in fact, if I just say, hey, give me object 0 in the deck, it just says, hey, you can't do that either, okay? And what if I want to iterate through the deck, right? What if I want to say, like, for each card in the deck, can we print out the card, okay? And it also says the deck is not iterable, okay? Or can I take, my hand and can I sort the cards in there? And all of these things cannot be done, okay? These, again, with Python's kind of object-oriented system, if you implement this one method here, dunder get item, suddenly all of these things, the way we interact with objects, will suddenly like come to life. Okay? You don't have to create this concept of slicing and concept of subscripting and concept of giving iteration and things like that. If you implement this dunder get item, all of these things that we just attempted will suddenly start to work. Okay? The way dunder get item works is you give it a key, which is basically going to be like an integer 0, 1, 2, 3, and then if we say, hey, you just have to ask, if I say deck square bracket 0, what is the item it should get? And in our case, we wanted to get the first card in deck.cards, right? So so that's what I'm going to basically do. Is I'm going to do define get item, self comma position, and the position is going to be an integer. And basically, self.cards is a list, and we're going to just say, hey, get square bracket that position there, okay? And that's it, okay? So so our class definition is getting bigger and bigger, but this get item is going to do the trick as far as making the deck class iterable and subscriptable and all of this stuff, okay? So here I'm using that, I will create a deck, okay? So here, this is all 52 cards of the deck. Now that I've implemented get item, I can say, hey, give me the first 8 cards, 0 through 8, okay? This is what it outputs. So it has subscripted. Now this is the using the repr, okay, representation. If I want it to print out so I can read it, I can say for item in deck 0 through 8, print that item. And now we get it, okay? Ace of clubs, 2, 3, 4, 5, 6, 7, 8 of clubs, and so on and so forth. So both of these things, the subscripting, the slicing, the iterating over it, now work based on just this single dunder method of get item. Okay, that's cool, right? Again, I'm a big fan. I'm a big fan of how Python makes working with all of these things so nice. Okay, so all of these other things that happened with slicing. So if you do 2 colons in your slicing operator, how is this going to work? So this is going to start at index 12. Go colon nothing means go until the end. Colon 13 means step size 13. So what's that going to do? So it's going to start at the 12th card, which is the king of clubs, and then it'll go every 13th card. So it'll go king of clubs, and then 13 cards later you'll have another king, a king of another suit, and then 13 cards later you'll have another king. Oh, okay, well that wasn't helpful. Okay, card 0, 13, card 1, 13, 2, 13, 3, 13. Let's print each of those things. Okay, king of clubs, king of diamonds, king of hearts, king of spades. Okay. All right, we have to redefine, anytime you have I redefined what it meant to be a deck, and remember hand inherits from deck, I have to kind of redefine hand to kind of use the new definition of deck, okay? So I have to just kind of redefine that. All right, so I'm gonna take deck. We have, okay, so here I have deck, new deck. We're going to do deck.shuffle. I'm going to move 5 cards from the deck into the hand. Okay. Okay. And then so because I have get item and I have a way to compare things, the cards, I can do sorted. Okay. So I can do for card and sorted hand. We can sort my 5 cards from least to greatest. Remember, it does all of the suits first, then all of the ranks. So it does 3 of clubs, then it would have done the diamonds, and then here we have the hearts, 2, 5, jack of hearts, and then king of spades. Okay. Remember, sorted does not actually sort the cards. It leaves the original hand in the order, and sorted just gives you kind of a sorted view. It takes the things and it sorts them for you to see what it would look like in sorted order, but not actually changing it. Okay. Oh, the other thing, when you have get item, you can also tuple unpack your the things in there. So hand, I have these 5 cards, jack of hearts, 3 of clubs, so on and so forth. I can also just tuple unpack it into five things, right? So I've got 5 things. I can say, hey, what is A? A is going to be 2, 11, which will be the jack of hearts. I can say, what is B? B should be 3 of clubs, and indeed, so we have that. So get item does all of these things of unpacking. Okay, let's, I forgot, what am I doing? I want to give you your view quiz. I've given you no view quiz answers, right? None. Okay, I got to log back in. Today is Friday. Gosh, why is this so hard for me? Week 8 Friday. Okay, first letter is C. C as in cat. All right, set item allows you to change things. Okay, so right now, so if I do hand, sorry. Okay, if I print the hand, I have this, right? And I can also ask, hey, what is hand 0? And I get this. But if I try to change hand 0 to something else, let's say if I want to change it to this, okay, it says hand doesn't support item assignment. Okay, so you can't change and say like, oh, I want to replace Jack of Hearts with something else. Okay, if you wanted to do something like that, you would do set item. Okay, so set item then allows you to basically set things that exist inside the object. So right now, with our current definition of hand, we cannot do this, but set item will allow you to do that. So so basically, set item will take 2 additional arguments beyond self. The key, which will be basically an integer, the location of where it's going to be set, and then value is going to be the thing that gets set into the thing. So here we're going to have define dunder set item, and we're going to do self, comma key, comma value, and then what we want to do is we want to say, hey, take the value and assign it to self.cards key. Okay, and now that we've done that, that allows us to then use these other things, other functions that use set item. So we used to have deck.shuffle. This is actually no longer needed. Okay, now that we've defined the set item, we can just kind of use the shuffle function that exists in like the random module of Python. Okay, so we don't actually need to have this random deck.shuffle. We can just call shuffle on the deck itself. Okay, so here I'm going to have deck. I can slice the deck. Here are the first 4 cards of the deck: Ace of Clubs, 2 of Clubs, 3, 4 of Clubs. What is deck 0? Deck 0 would be the Ace of Clubs. And I can change this, and now that I have set item, I can say, hey, change that first card from the Ace of Clubs into suit 3, which will be the spade, right? Ace of Spades. And so now if I say, hey, what are the first 4 cards in the deck? Now I have Ace of Spades, 2 of Clubs, 3 of Clubs, 4 of Clubs, right? So this is like a cheater's deck. Now we've removed 1 card and swapped it for another card, okay? And we have that. The other thing, now that I have set item, rather than calling deck.shuffle, which is fine, but again, Python kind of wants you to not redefine new methods here, but just kind of use these dunder methods that allow you to kind of use these existing functions. So one of them being random.shuffle. We can just call random.shuffle on the deck itself. Okay, and so now the deck has been shuffled, and I can say, hey, print the first 10 cards of the deck after it's been shuffled. Okay, I can still call sorted on the deck and look at sorted on the deck. We no longer have an Ace of Clubs, and then you'll see down here I have 2 Ace of Spades. I got card 3, 1 that shows up here. Maybe I can call print unsorted deck. Oh no, that's not what I want. Sorted, what do I want? I guess for I and sorted deck, print I. Okay, so you can see we have Ace of Spades shows up twice, and we have no Ace of Clubs. Okay, but the deck is still kind of in this shuffled state because we called shuffle on the deck. Okay, this I'm taking straight from, this is just one little thing that I've taken from Fluent Python. There's kind of, there's a lot of stuff in here. In this one, we have let's say we want to create a class that represents a vector in 2 dimensions, okay? So we're going to call class vector 2D. And this thing will contain 2 attributes, basically an x coordinate and a y coordinate, okay? And we'll store them as floats. There's a dunder iter. Iter makes, it's a little bit like get item, but it's different in that it just makes the object iterable and unpackable. So you can kind of, so what this does is it creates a tuple out of self.x and self.y, and then when you say iterate over this, what it's going to do is it's going to return I in basically for I in self x and self y. So it'll just kind of iterate over that. We have a representation and we have a string. And the representation, one thing you can do is you can also call type.self double under name, and it'll just take basically vector 2D here. So so here we'll create a new vector with coordinates 3, 4. And when we call the object there, we get the representation, vector 2D in 3.0, comma 4.0. The string is 3.0, comma 4.0 as a string. Okay. One issue though is these attributes, self.x, self.y, the x and y in this thing, these are what we call public, and they're publicly accessible. And so I can just change my vector.x to be dog, and then now my vector contains dog in 4.0, right? There's no kind of, we don't have any kind of check here to make sure that it, there's no validation or something like that, okay? So if you want to prevent something like that, you can use these, quote, kind of private attributes. They are not truly private in that Python still has a way for you to kind of access them and modify them directly, but Python kind of makes you jump through a few hoops to get it, to kind of discourage somebody from doing it, right? But it never actually fully takes away your ability to go in there and modify stuff. But it just says, okay, I understand you no longer want to modify this, so we will make it difficult for you to modify, but just in case, here's this secret entrance where you can still modify it, okay? So it's not like truly private where everything is truly off limits, okay? And so, so the way you would do this is you will rename your attributes to and precede them with 2 underscores. So instead of having self.x, you will have self underscore underscore x, okay? And self underscore underscore y. Okay, and you might notice this in some of other functions and stuff. Single underscores, if something is preceded by a single underscore, it's kind of a message to the end user, like this isn't something you're supposed to access directly, okay? It's kind of like on your computer, like when you use Git and stuff, it creates these folders where the first letter of the folder is a dot, right? You have like .init and, or like .git and or what, I don't know, whatever, right? And that's kind of a signal to you, like this is not a folder that you should be messing with, right? It's kind of by default, they're hidden. They don't show up when you do list, but when you do list all, they're there. And if you wanted to, you can navigate in there and mess around with it. But it's kind of a signal to you like, listen, we don't want you messing with it. And so when you look at kind of Python code and things like that and the outputs, you'll sometimes see like single underscore variable name, and that's kind of a signal to you like this is not something you're supposed to be messing with. And then double underscore is kind of like, really, don't mess with this, okay? So here we have double underscore x, double underscore y, okay? But if we want to access x and y, we can define a function called x, right? So we'll do define x self, and this will return self dot double underscore x, okay? For this to work though, this is something called a decorator, okay? And I have not talked about decorators at all, okay? Python has these things called decorators, and and they look funny. You have at property here. Python comes with kind of different decorators. You can read more about decorators on this thing. You can search more on Python decorators. They're kind of like functions that modify other functions. They give it a certain thing. But this will basically make allow you to access these values so that you can kind of look at them. Okay. The other stuff, the iter, repr, and string are the same from before. Okay, but basically, I've just kind of put in these two new methods so that if I call the vector.x, it will return self dot double underscore x. Okay, but we put in this at property decorator. Okay, so now I'm going to create a new vector, 3, 4. And then I can call my vector.x and I get the value 3.0, which I want to be able to do. But if I try to change the value to say dog, that doesn't work. Okay? And then if I try to access double underscore x directly, I can't do that either. Okay? I get this thing that says vector2d object has no attribute double underscore x. Okay? Even though it is something that exists inside the thing. And that's because Python understands that this double underscore business, like, it doesn't want you to do it. Okay, there is, again, the secret workaround. It's not a secret, but it's, if you really wanted to access this value directly, you can, okay? And you get it by doing single underscore, the class name, and then the attribute double underscore x here. Okay, so you take object underscore whatever the class name, and then double underscore whatever that private attribute is, and then so now you can access that. And then if you wanted to, you could change it to dog. Okay, and my vector will now have this. Okay, we'll have that. But again, this is the whole point of this double underscore thing is so you don't do stuff like that. Okay, so it really doesn't want you to do that, but you can. The Python never fully takes it away from the developer or the user, the ability to kind of get into those values. But it basically, you have to jump through some hoops in order to do that. Okay. All right, let me give you your next view quiz answer, which is the letter A. A as in apple. Okay, a few Pythonic features. Just a few more like little things that Python does that these are like nice. You might have seen some of these things already. Okay. Here is, I've got x is equal to -3. And if we wanted to say, like, if we wanted to take the log of -3, that would normally throw. So let me do like import math. And then if I do math.log of x, we will get an error, value error, math domain error. Oh, that's so helpful actually, right? You're like, oh yeah, I'm trying to put something in. Can't do that. Now we could write kind of this control, flow control structure where we can say first check to see if x is greater than 0, and if it is, then go ahead and calculate the log. Otherwise, return a nan. Okay, I don't know. Maybe I should do x greater than or equal to 0, because I think you can do math.log of 0. Math.log 0, does it do negative infinity? Oh no, it doesn't like it. Doesn't like it at all. Okay. All right. So never mind. You can't plug in 0. All right. So anyway, if we do that for x, we get a nan. Okay. You can express the same kind of idea here, just concisely, and you can just say, hey, y is equal to math.log x, but you put in the condition after the fact. And so you'll just say if x is greater than 0. Otherwise, return a name. Okay, so there you go. So that's a conditional expression. It's just basically you put in the if statement after the expression that you want evaluated. So it's kind of, it's like in English, as you're speaking, you can put your modifier up front or after the fact, and people understand. And likewise, Python kind of gets it too. So it's kind of nice. Okay, and so there's like you can even use like recursive functions within a conditional expression. So again, you can, a simple way to express a factorial function is to do it recursively, and you'll say if n is equal to 0, return 1, otherwise return n times factorial n minus 1, and you can do it this way, and you can get factorial. Or you can also define your function this way. This might make it a little bit harder to read, but it works, okay? I guess just to show that like these conditional expressions are not limited to just these simplest of cases. So you can say return 1 if n is equal to 0, otherwise return that, and then it works, okay? Still works, right? Okay. Variable length arguments and keyword arguments. Oh, we've already talked about this, but you have star args and star quargs, which will either kind of gather or scatter arguments here. So here I'm going to just call define print all star args. This will allow you to put in some kind of variable length argument. So you can put in anywhere from 1 to I don't know if there's an upper limit on how many values can be gathered. There might be. All right, and then and we can just iterate through all of them now. Okay, so they get gathered into a tuple. Print all of them. Basically, 1, 2, 3, 4, 5. We'll print them all out. Okay. So let's see if we can understand what this thing is going to do. Okay. So we're going to import random int. Define roll star dice. Okay. So here's it's a little bit of a clue here of what it's going to do. Okay, the total is 0, and then we're going to say for die and the dice. So star dice indicates we might be getting multiple values in here, each of them, I guess, representing a die, and then we're going to roll random int 1 comma die. So we want one random integer from die. Okay, so if you do like randint 1 comma 6, it'll give you basically a value from 1, 6, and then so we'll print that out. We'll add the roll to the total, and then at the end we'll return the total. Okay, so if I do a roll 20, this is like rolling a 20-sided die. We get a 12. Okay, here if I run it again, I get 11. A 14, I run it again. Okay. Roll 6 comma 6 comma 20. This would be the equivalent of rolling 2 6-sided dice and 1 20-sided die. Okay, so here I get a 1, 5, and a 2 for a total of 8, a 3, 3, and 8 for a total of 14, a 1, 3, 15 for a 19, 4, 5, 6, 4, 4, 8. So I guess if you played some kind of tabletop game, a lot of times you'll roll a 20-sided die for your primary, I don't know, whatever,
skill check.
your skill check or something, and if you have a modifier, you might get to roll an additional 4-sided die or something.
Yeah.
to do something like that, right? So you can do that with something like this, right? So you can you can put in a 4-sided die here and get that, okay? So there you go. Give me a perception check. All right.
Yep.
Okay. And then, similar kind of things with keyword pairs. Basically, you can provide it like keys and values. Okay, so you star quargs, you'll get values and keys once it kind of orders them together, and you get quargs.items, and then you can kind of iterate over that. So this is like a dumb example, but here I can put in California and Ohio, and we'll do that. And then as far as this goes, you can kind of you can also zip these things together. Okay, so here I put in CAOH TXWA for California, Ohio, Texas, Washington, and then so if you try to just kind of print a dictionary, so I'm sorry, if I call print contents on this dictionary directly, it doesn't like that. But you put in double star, okay, star here, then it will kind of scatter the entries in here in this dictionary into the keyword arguments, and then it works out, okay. And so you can do that. So again, you have zip. Let me see. Will it work on the zip directly? Print contents. No. What if I scattered the zip? No. Okay. So I guess you got to create a dictionary out of the zip. Okay, so that'll work. So you can't do it directly with the zip. You got to turn it into a dictionary first. Okay, but we have that. Okay, I guess that's it for today's lecture. We'll end a couple minutes early. We have a extra weekday off for the weekend, so enjoy your Monday off, and we'll see you guys on Wednesday.